Hello. So today we are going to create a smiley face using maths. So so this is basically shadertoy.com. It's a web browser. It's a site in which you can program shader programming. How this works is, so we have here a main function, main image. So basically this use GLSL language. If you want to know more, you can search on web and you will get to know what it is. But basically what this function does is whatever you write in this function, right, it will call for all the pixel in the screen. So these are, let's say this is my screen, okay, and these are the pixels. So whatever we write in this particular function uh, will be run for this every pixel. So it will run for this pixel and then this, and this will run parallel. So that's why it's so fast. Like we'll have like HD screen in which we have 1920 into 1080 pixels, right? So it's like lot of pixels, and it will run concurrently on all these pixels. And how we'll know that in on which pixel we are? So we have a term called UV, right? So we have UV. I don't know why it's named UV, but basically for any screen, very standard UV goes from like 0 to 1 for x-axis and 0 to 1 for y-axis, right? So this is our whole screen, and it will go from, so here it will be 0 comma 0, here it will be 1 comma 0, and here it will be sorry, 0 comma 1, right? So so this is how UV works, right? And we can scale according to our need, but this is the very standard thing, right? So here you can see we have frag color. So frag color is the output of this function. Basically this function returns a color. As I told you, it will run for every pixel and it will return a color, and then that particular pixel will get colored whichever the frag color we have returned, right? And then we have frag coordinate, which is which is a fragment coordinate, and by dividing it by resolution, so basically our screen width and height will get UV. So basically this is UV 0 to 1, right? So let's delete this thing, right? And now what we will do is, uh, first of all we'll run it, right? uh, so we'll compile it, and there is an error because color doesn't exist, right? So what we can do is we can just do one color, and we right. So we can compile here. So now our all screen is white. Why screen is white? Because for every pixel we are returning this vector 4, which is color. So this is comprised of R, G, B, and alpha value, right? So red channel, green channel, blue, and alpha. So we have passed one into all of them. So that's why it's white color. Okay, so now uh, let's look at UVs, right? So what is UV compromised of? So what we can do is we can do UV, and then for, so UV will become R and red and green, and then blue will be 0 and alpha will be 1. So if I run this, so as you can see, black color means 0 comma 0. There is a red because red is R channel, and it is kind of like X coordinate, right? So let me explain how this works. So basically color is a four dimensional vector. It has a four values. So one, which is red, green, blue, and alpha, right? So it's a four-dimensional vector. And also you can think of it as a, this is X component of Y, so this is Y component, this is Z component, and this is W component, right? So you can think of it that way also. So basically these are X, Y, Z axis, right? Yeah. So that's why we are looking red color, because it's 1 comma 0, right? So because it's red color, here it's 0 comma 1, so it's green color, because we are representing y-axis as a green. So as you can see, we have 0 comma, it's start from 0 comma 0 to so basically it goes from 0 to 1. But we don't want that. So what we'll do is we'll minus vector 2, 0.5, right? So now when you run this, as you can see, now it's 0 comma 0 in the middle. So it's going from minus zero point 0.5 to zero point 0.5, minus zero point 0.5 to zero point 0.5, right? Because what we done is we have shifted our origin by zero point 0.5. So we have shifted our origin to the zero point 0.5 in the center, right? So if I do new layer, right? So we had our origin here, right? And it's from 0 to 1 and 1. So what we done, we have minus zero point 0.5, so it's shifted to here, right? Okay, so now let's start on the first thing. We'll draw a circle on our screen. Okay, so how do we do this? So as you can see, we can't just define any boundary and draw a circle, right? So we have to do it mathematical. So how you do it? So let's go here and let's clear this. So let's say this is our screen, right? Okay, so now we need to draw a circle, right? In here we need to draw a circle. So what is the property of circle? According to the property of circle, or whatever shape we want to draw, we define a distance field for that thing, right? Or you can say sign distance field also. So if you want to know a bit more about SDF, you can search, right? It's a very important topic in graphics programming, because everything we draw we use sign distance field uh, to draw, right? So basically we think about a shape and its property. So basically what kind of property circle has? So we know that each and every point on the circle is equidistance from its center, right? So that which we call it radius, right? So what we can do here is we can make a field on the screen which represents this kind of feature, right? So this kind of property. So how we can do that? So very simple. It's very simple. That what we do is we take each and every pixel on the screen and calculate a distance from the origin of the circle, right? So center of the circle. So uh, so we calculate distance from each and every pixel, right, to center of a circle. Let's say this is O and this is like every point on the screen is P. So every pixel on the screen. So what this will give us is a distance field in which at the center of a circle the distance will be 0, and as you move away the distance will increase, right? So this is what we called as a distance field, and then we'll use the distance field to create a circle. Okay, so let's see how we make a distance field in a code, right? So what we'll do is we need to draw a distance field. So we'll make a float m in which we'll store the distance, and basically there is a function called length in which you can pass a point. So basically uv is our point, right? So uv will go from basically uv is a kind of like, you can say, the position of pixels, right? So for each pixel we'll get the pixel position, and then we'll find a length, and then uh, we'll define a vec3 color in which we'll pass this, and then here we will make it color, right? So we compile. So as you can see, you can see the distance field, right? But you see elliptical shape, right? Why you see elliptical shape is because our uv coordinate is not normalized, in terms of not normalized, because our width is greater than our height, so it's not actually circle. So what we'll do is we'll multiply our uv coordinate x with I resolution dot x divided by I resolution dot y. By doing this, uh, by doing this, we are actually normalizing, and if I compile now, you can see earlier it was stretched and we multiplied by aspect ratio of our resolution, so now it's not stretched, and now you can see the distance field, right? So it's and you can see the circle shape also, but it's not actually circle, it's just an distance field of a circle, right? But how do I make circle out of it? So the name of the function is smooth step function, right? So it's a smooth step function. So what smooth step function does is basically a mathematical function. So if I draw our xy axis, right? So basically it's an y axis and x axis. So this function goes something like this. So it let me draw in a red color. So it's come like this, then it will go like this, and then it will stay, right? So basically this is 1, this is 0. So it will stay 0, and in duration 0 to 1 it will increase to 1, and then it will stay at 1, right? So now what is important of this function, right? So basically you can think of this as a switch, right? So basically uh it's a switch, because it will return 0 for all the value less than 0, and it will return 1 for all the value greater than 1, and in between 0 to 1 it will smoothly increase to 1. So it's kind of like a switch. So you can multiply this function to other functions to get in to just implement this effect and nullify all the things before and after. So the we'll look at in an application form, and you will understand how this works. But it's not just 0 to 1, you can also modify it. So basically smooth step function takes an argument a, b, and t. So basically this t is input, right? And a, b are parameters where it will be 0 or not 1. So basically if t how this works is, if t is less than a, so basically if t is less than a, then it will return 0. If t is greater than b, then it will return 1. And for t in between a and b, it will be it returning from 0 to 1 value. So it will be increasingly, it will be softly, it will gradually increase from 0 to 1 in between a to b, right? So how will we use this function? So uh, as I told you, we have a distance field, right? So we have a distance field over here, in which the distance is continuously increasing. So now what we can use is we can make a boundary using a smooth step function. So we have a distance field which is going from 0 to some amount x, right? So we have distance field. So our t, basically this is our t, right? So in smooth, I'll write the definition of smooth step function here, a, b, and t. So basically our t is our distance field, right? You have to think about, so our t is going from 0 to x, right? So t is going from 0 to x. Now, so a and b will be our thickness, kind of like defined a parameter where how a radius or how big our circle wants to be, right? So let's say if I pass a zero point 0.5, right? And b, and so a will be 0.5 and b will be 0.6. So if a, so our t, when t is less than 0.5, so basically from here to here it will return 0, right? And from t, if it's greater than zero point 0.6, which is here, let's say this is zero point 0.6, and after this it will be 1, and here it will be from 0 to 1. So now you can see it kind of like uh, creates an effect on our distance field to create a circle. So let's see in the action. So what we'll do is uh, we'll so we'll call this float t because it's a distance field, and then we'll call this particular variable m for mask, because we are masking on our distance field, so that's why we call it mask. And this have a smooth step function which is comes in this particular library of this language. You don't have to write smooth step, which is if you want to write your own smooth step function, it's not very hard also. Comment down below if you want to know how smooth step function works in terms of what is actual math behind it, and I'll make video on that also. So let's do 0.5, 0.6, and pass in d as a t parameter, right? And let's run this. So as you can see, we got a circle, right? But it's a kind of like little big. So what we'll do is we'll reduce this to this. So now it's a circle. But as you can see, our circle is not sharp, right? There is a blur to it. Why? Because the difference between A and B will define the period of the blur, right? So what you can do is you can make this blur very small. Like if I do zero point 0.3 and 0.31, now it's kind of like very sharp circle. But uh, if what if you pass bigger value here and smaller value here? So what we'll do is it will inverse the effect, right? So basically it will inverse the effect. Now we'll got white and inside and outside, right? So this is a smooth step function, how it works. So amazing, right? So what we did is we created a distance field for our shape, and then we apply a mask of smooth step function, which basically gives a result of a particular shape which we want. So nice, we got a circle, right? So now let's color our circle. So for coloring our circle, what we can do is we have color here, and we can just multiply it by any color here. So basically it's an RGB value. So let's say we want, smile, we are making smiley face. So let's give it a yellowish color. So how we make yellow? So if you remember color theory, which we studied in child, it works like it's a mix of red and green. So red will be 1, green will be 1, blue will be 0. And if I run this, you get yellow color, right? You can play around the value of this thing to make it so. uh, let's get something orangish. So if you, yeah, so it's quite orange. Yeah, nice, I like this color. So it's kind of like not pure yellow, it's kind of like on the orangish side of the yellow. Okay, so now we learned how to create a circle, right? But now we want to create more circle for eyes and stuff. So what we'll do is we'll create a function for here, circle, uh, which will return, and we'll take these variables here. Okay, and here we'll pass two things. One will be UV and one will be our particular position, right, where we want our circle to be. So earlier what we were doing is we are finding UV length, right? So basically what we are finding was from the center of the circle, from the center of the origin. But if you want to place this particular circle in other parts, and you want to move your circle, so we have to pass our center position of the circle, and then basically we'll minus that position from our UV. So basically we'll get the distance from all the pixel from this particular point, right? So we'll find distance field relative to this particular point. Okay, and we'll return M here. Okay, so okay, that works. And let's here float M will be equal to circle. Oh, I wrote my spelling. I can't spell circle. So we'll pass UV and we'll pass in position. So for now, let's just keep it on center. And if we run, it will give the same result, which is what we want, right? Now let's say move our circle, right? So if I do this, so it will 1 comma 1. So it will move our circle 1 comma 1. If I run it, so it got out of the screen. Why? Because we are our screen is going from UV minus 0.5 to 0.5, and 1 comma 1 is outside of the screen. So let's do 0.5, right? So it will move our circle zero point 0.5 comma 0.5, so it will go here, right? And if I move it 0.5 in x-axis and not in y-axis, so it will shift 0.5 this side, and if I do minus 0.5 it will shift to this side. Okay, let's keep it at origin. Now let's control our radius, right? Because we have fixed our circle radius in this. So what we'll do is we'll pass in parameter called radius, and what we'll do is we'll pass radius here, and then we'll do minus zero point 0.1, right? So we'll pass in radius, and then to make a circle of that radius, we'll minus zero point 0.1 in the b value of smooth step, so it will retain. So now we have to pass radius, so let me pass 1 point, so it's a very big, right? So let me pass 0.2, and now you can see it, we got a 0.2. And let me make this value much smaller to get a sharper well, uh, sharp well. And let me make it more bigger. Let me make much more bigger. Okay, I like it. Okay, so now let's make more circles for eyes, right? So what we'll do is we'll create another mask for circle, in which we'll pass UV, and here we'll pass. So basically this is 0 comma 0, so we want to move our eyes to here, right? So basically, so it will be, let's say, minus zero point 0.1 and minus 0.1. Let's just guess this number right now, and we'll see. And we want to make it smaller than this particular, so let's make it 0.1, right? And we'll just see this, we'll only see this particular circle for now. So as you can see, it's below, so we want to do plus in the y-axis, so now it's here, and let's make it shift more to that side. Okay, now we can only see one circle at a time, right? So either I can see this circle, or I can see that circle. How we can see both of them? So uh, basically, what we want to do is we want to cut out. We want to put our circle here, and we want to cut out that circle from this. So very simple. We can do is we can do m minus. So we can from this particular value we can minus this circle value, and if I run it, basically I'm getting some what? Oh, I don't need to define. Yeah. So as you can see, what we are doing is we have created a bigger mask of the circle, right? And then we subtract another mask of a circle from M, right? So that's why we have got out, and we can move it slightly here, so it comes, and yeah, yeah. Okay. I like this position. So now what we can do is we can duplicate this line, and basically we'll make this value positive, and if I play, we get another eye. So we got eyes, right? Now let's say now we need to create a mouth, right? So how will we create a mouth? So let's go into the back, into the board, and now let's say how we'll create a mouth. So basically the how what we can do is we can draw one circle, right? And we can draw another circle, and we can just keep this part, right? Which will become a mouth first. So we'll draw one circle, and then we'll yeah, and then we'll cut out this part, this particular portion from one circle. So right, how we'll do that? So Let's create the mouth for this, and let's create a circle. So we'll visualize mouth first, right? And so circle will be UV, and vector 2 will be 0, and let's make it 0.3, right? So if I compile, we got a smaller circle. Now we'll subtract another circle from this. I can't spell circle. So UV, and what we'll do is we'll shift this particular circle which you want to minus little bit above, right? So it's currently on point 0 axis, so we'll move it up like 0.2, right? So let's move it 0.2, and we'll keep it as the same radius, right? And if I compile this, something went wrong. Okay, I forgot the comp. Okay, if I compile this, as you can see, it's kind of like cutout, but it's a little bit too much bigger. So what is happening? I went into some, yeah. Okay, so this is okay, right? This looks good. Let's experiment a little. No, this is not good. If we do this, okay, so we are making a radius a little bit. So the second circle, we are making it little bit more to, cut out the more side part, and let's move it up a little bit and little bit down. Okay, I like this one really well, right? So this is a really good mouth we have. So now what we'll do is we have our mouth. So basically what we'll do is we'll cut out our mouth part from our main mask, right? And if I compile it, and if I put color, if I put my mouth back, so here we got. So it's really nice, but you can see there are weird parts here, right? It kind of like, it become kind of like weird looking. So but our mouth was good, right? Our mouth has no such thing as that. So if I only see my mouth, it's it should work, right? Why it's not working? So why it's not working is because what we are doing is we have this one circle, and we are subtracting another circle from this, right? Basically we are subtracting another circle from this. So let me choose another color here. So this particular whole circle will have value of 1, right? So blue will have value of 1, and then this particular circle will also have value of 1, right? Now when I minus, when I do when I do this circle, so blue circle, when I do blue circle minus red circle, right? So this all part will become 0, right? So these all will become a 0. So let's use another color for this. So this all will become 0. But what will happen to this part, right? So this part will be, because here it's 0, and here this part we are 0 and we are minusing 1. So this will return to -1, which we can't see in the colors because -1 will be also return. So anything below 0 is black, and anything above 1 is also white. But in mathematical we'll have -1, but in terms of screen we'll not see that. But when we combine all of the stuff here, when you do m minus mouth, so where our value is -1 for the mouth, it will add into our M, right, rather than subtracting. So what we need to do is we'll need to give it to the absolute value, not absolute value, but we need to clamp this particular function to 0 comma 1, right? So whatever the value is, we'll clamp it between 0 to 1 because we don't want negative values, right? If I compile now, right, and if I render my main mask, okay, it's still behaving weird. Oh, my bad, my bad. So we don't need to clamp this, my bad. Uh, we need to clamp this mouse position whenever. So we'll clamp this, and now you can see because now we are eliminating all the negative values from the mouth because we are clamping it from 0 to 1. So now it looks really nice, right? So I hope you enjoyed this video and learn how we can, how actually the Photoshop and software like Photoshop and other works, right? So behind the scene, this is all it's going on. When you draw a circle on any Photoshop like software, right, photo editing software, basically this kind of code gets working. Here we have made circle function, so they have circle function, but these all parameters you are passing is with your mouse, right, and the tools you use in those software. So this is how we do how we render stuff on the screen, right? So hopefully you all like the video, like and share and subscribe for new other videos like this, and we'll make animation for the smiley for the next video, and we make it animate